Okay, let's look at quiz 3, which is kind of covering chapters 3 and 4. The topics in this quiz are going to be, our solubility rules and writing ionic equations, both the net and complete ionic equations. So let's start at the top. So we're asked to write the balanced chemical equation for the following reaction. So we have iron 3 sulfate and lithium hydroxide, and they're dissolved in water. And we need to figure out what happens when we dissolve those two compounds into water. And the first thing we need to recognize is that both the iron 3 sulfate and the lithium hydroxide are ionic compounds. And if you remember, ionic compounds, when you put them in a solution, they're going to dissolve. And they're going to completely dissociate into their constituent ions. So what we mean is if we put something like lithium hydroxide into water, we assume that it's going to separate out into the cation and the anion, the metal and the nonmetal. Right? And we assume the same thing for iron 3 sulfate. But the question is, not everything is soluble. Not every ionic compound is soluble in water. And so we have a list of rules that we went through in our lecture, or if you do a Google search for it, if you look in the book, right, there's a list of the solubility rules. And it's always going to be given to you on the exam, right? I'll just scroll down here. Here's a set of the rules for what we're going to be using. Okay, so let's look, right? Here's our buddy sulfate. It says that, right, if we look at the top here, it says the compounds are generally soluble. So sulfate compounds are generally soluble. Are there any exceptions? It says, well, there's exceptions with strontium and barium and lead and silver and calcium. Well, we don't have any of those here. Right? We don't have any of those here, so we assume that the iron 3 sulfate is soluble. Okay, lithium hydroxide. Right, we're looking right here. There's our buddy lithium. No exceptions. Right, so every lithium compound is going to be soluble, is what we know at the moment. Great. So both the lithium hydroxide and the iron 3 sulfate are soluble in water, according to our rules. So we need to start this reaction, right? We need to start what's going on here. Let's see if I can keep this color-coded here. All right. So if I take my iron 3 sulfate and put it into water, it's going to dissociate into its respective ions. So we have two irons, right? Two irons, and the charge is going to be 3+. Now, if you don't know how I got that 3+ charge, I'm not going to cover it in this video. I talked about how to do that in my naming videos or my ionic charges videos. Please go back and see that, right? So we have two iron 3+ ions, and we have 3 sulfate ions that form. Sulfate, one of our polyatomics. Okay. We do the same thing here, right? Lithium 1+ and OH 1-, right? Okay, so these are the things that form when you put them in a solution, right? Now we have to be careful here, right? We have to be careful. Now what is going to come together, right? So now that we dissolved all this stuff in a solution, right? Now that we dissolved all this stuff in a solution, we need to figure out what compounds can get made. And so here's what I mean. We need to make new combinations of our cations and anions, right? So the first thing we did, right? Step 1 here, right? We dissociated everything. Whoops. Don't know why that, okay. We dissociated our ionic compounds. We checked our rules, right? Step 2, right? Make new compounds. So now that we have our individual ions, we need to make new compounds. And here's what I mean. Right? So let's say we take the iron and we mix it with the hydroxide. Right? And we take the sulfate and we mix it with the lithium to make a new compound from those respective ions. Now, why did I pick the iron and the hydroxide? Why would I say the iron goes with the hydroxide? Well, here's the reason. A plus and a minus. A plus and a minus. Right? We're looking for ion pairs. Something plus is always going to look for something minus. There's no reason, I don't have a new color, so let me just use blue for a second. There's no reason why iron is going to go looking for lithium, right? They both got plus charges, right? It'd be useless to do that. Just as there's no reason the sulfate would go looking for the hydroxide, right? There's no need for that. So you make new compounds based off of the charges that we dissociated in step 1. Right, so let's write out our new compounds. Now we have to be careful. Please be careful in this step, because we have to pay attention to the charges. For instance, the charge on iron is 3 plus, the charge on hydroxide is 1 minus. So our new compound, right, we have to make a neutral compound, is going to be iron 3 hydroxide. Okay, because we have to balance out that 3 plus charge. And we're also going to make, right, lithium sulfate. Take a look at your charges. Sulfate 2 minus, lithium 1 plus, so we need 2 of them. All right. I'm just cleaning up a little bit here. And all right, so there's step 2. Okay. Step 3. Well, let's write step 3 in black. Check solubility. So check solubility of the new compounds that we did in 2. Okay? So we go back to look at our rules. So now we have iron 3 hydroxide and lithium sulfate. So let's go back to our rules. Right? There's our buddy lithium. It's always going to be soluble, right? There are no exceptions. So what does that mean about lithium sulfate? Well, it's going to go into solution, right? It's going to be aqueous. Well, we'll talk about what that means in just a second, right? But for the moment, I just drop an AQ next to it, so I know that it's going to be soluble. All right, now we go look for our buddy hydroxide. And here we find our buddy hydroxide. These compounds are generally insoluble. They're generally insoluble. Are there any exceptions to this? Well, yeah. There's exceptions when we're dealing with lithium, sodium, potassium, or ammonium, right? Those are soluble. Well, we don't have lithium, potassium, or sodium, right? Or ammonium over here. We've got iron. And so we assume, based off the rules, that it is insoluble. So if it's insoluble, it's going to precipitate out of solution. So we put an S next to it because it's going to form a solid. Got it? So the S, right, it's going to precipitate out because it makes an insoluble compound based off of our rules. And now we got to go through and write our balanced chemical reaction, right? Now we identified everything we need. Now we write our reaction. So let's do this in blue. So let me see if I think I've got some space here. So our compound, our initial compound, we dissolve those into water, right? Aqueous. Plus lithium hydroxide, aqueous, soluble in water, goes to make iron hydroxide, solid, plus lithium sulfate. Okay. So, right, all we're doing at this point, all we're looking at this point is we wrote out our equation. Let me see if I can clean this up just a second, right? This should all be AQs for aqueous. Right, the aqueous is just telling us that it dissolves in solution. But are we done? Well, the answer is no, not quite yet, right? There's a hint in the question, right? It's saying we want a balanced chemical equation. We want a balanced chemical equation. So we need to go through and balance our new equation here, right? We need to go through and balance our equation. Okay? So I'm going to just go through. I know what the answer is, right? This should be 2, and this should be 3, okay? So I just went through and balanced the equation based off of what we have. All right. So just to recap what we did for part 1 here, we used our solubility rules, right, in red there. We dissociated our initial compounds, right, to make our initial ions here, right. In purple, right, we made our new compounds by bringing together the anions and the cations. We rechecked our solubility rules for the new compounds, and then we wrote our balanced chemical equation. Okay, question 2. Identify the spectator ions in the following reaction. Now, I'm going to work through this a long way, and there is a shortcut to it. Okay? And here's how the long way works. Well, the long way is going to be very similar to our steps up here, right? So the first thing we're going to do is dissociate. Let me do this in red so it kind of remain consistent here, right? We're going to dissociate everything in our equation here, right? We're going to dissociate everything in our equation. And that would be known as the complete ionic equation. Okay, so we're going to dissociate everything. Now, I should be cautious, right? Because we're going to dissociate all soluble compounds. Okay? We're going to dissociate all soluble compounds. Is AgCl, is silver chloride, soluble? The answer is no, right? The answer is no. Silver chloride is not soluble. Okay, how do I know? Well, there's my buddy chloride, right? And there's an exception when it's paired with silver. It is not soluble. The other way you can tell, right, is that it's got a S next to it, right? That means it's a solid. It will not dissolve in solution. If it will not dissolve in solution, it will not dissociate, okay? So if it will not dissociate, we can't break it apart into its individual compounds, all right? So look for solids or look for things that are labeled as liquids, right? And those will not break apart when you put them into solution. So let's go through this. Let's dissociate. Ag, 1 plus NO3, 1 minus, AQ, Na, 1 plus, AQ, Cl, 1 minus, AQ. I'm going to switch over to blue, and we'll see why in just a minute. Goes to make AgClS, right? We do not dissociate solids. Plus Na, 1 plus NO3, 1 minus, AQ. So what we just finished was our complete ionic equation, right, where we dissociated everything that was soluble. Now it's kind of like a math equation to get to our net ionic equation, right? If we wanted to figure out what our net ionic equation was, and don't worry, I know what the question is. I'm making a point, right? If we wanted to write our net ionic equation, we would cancel out whatever species exist in the red and in the blue. And here's what I mean. Here's our buddy sodium, and here's our buddy sodium. It exists as the exact same thing on both sides of our arrow. So we can basically cancel it out, right? We look for something else. We see our nitrate and our nitrate. Can we cancel anything else out? Well, no. Okay? We cannot. So our net ionic equation would be this. Okay? Now, a net ionic equation is basically just the stuff that goes into the reaction to make our precipitant. The things that we canceled out, let me do it in purple, right? So spectators. Our spectators are the things we canceled out. We canceled out the sodium, right? And we canceled out the nitrate. the things that are not in our net ionic equation. So the things you cancel out are our spectator ions. And what's left over is our net ionic equation. Okay, so when you write your net ionic equation, you're figuring out what your spectator ions are. If you know what your spectator ions are, you know what your net ionic equation is going to be, right? So one kind of tells us the other. Got it? So the steps were, we dissociated all soluble compounds. We wrote our net ionic equation by canceling out ions that exist on both sides of the equations. And we finished up by just identifying that spectators are the things that we canceled out. Question 3 was just a simple application of the rules, right? What happens when the following are dissolved into water, right? So I'm just going to quickly blast through this. Fe2 plus, 2Cl, 1 minus, okay? Be careful, it's not Cl2, 2 minus or something like that, right? Remember, the 2 here, the 2 at the bottom, indicates that that is part of a compound, right? The 2 out here is a stoichiometry thing. It tells us how many atoms. Okay? It's not that. Get rid of that. Okay? You break everything down into its individual components. Here, NO3 minus. Our buddy HNO3 is nitric acid, and one of our strong acids. Right? It's when you put that into water, right, it separates into its constituent ions. K2CO3, right? We have 2 K1 plus ions, and a CO3 a carbonate ion. Cesium hydroxide, right? Our rules say that hydroxides are generally insoluble. So, right, no ions. Although it depends on what source you're looking at, to be honest. Some sources say that cesium ion is soluble. Some say it isn't. So it might depend. So I'll give you guys both answers here. I accepted both answers in this case. I didn't mean for this to be a tricky question. But there it is. So if we follow the rules presented, right, they say they are generally insoluble, although cesium hydroxide technically is somewhat soluble. Okay, so I'm going to zoom out. There you guys go. There is quiz number 3, dealing with precipitation reactions, net ionic, complete ionic equations, and solubility rules.